I'm actually really excited to be here. This is a really cool subject, and so I'm glad everyone who's listening in, hopefully you'll find some really some ideas in here. Imagine, if you will, that your organization has been given the green light to move your web application and maybe some of your related workloads into the cloud. And a lot of times when we do that, we're like, okay, we want to take advantage of the services and the protections and the security controls that your cloud environment provides. But you aren't really sure like where to apply them or how to change what you're doing now when you move into the cloud. Or maybe you're in a situation like most of us where you didn't get to spend the time and energy locking down or protecting your infrastructure like you really want to. I mean, you've got so many things you're dealing with. Usually you're deploying new systems faster than you can manage them, and you don't want to bring bad habits with you to the cloud. Or maybe you're already in a cloud environment and you have your systems in the cloud, but you want to know, where should I apply my next round of focus, or where do I should be focusing on time? What are the biggest risks to my web application and my related workflows that I need to be focusing on next? So this talk, for the first half, what I'm going to talk about is how to secure your modern web applications, and looking at the process by where you analyze and figure out what are my biggest risks coming from threats, and how do I properly address those threats, and how do I mitigate them, and where to invest my time and energy. So, well, that's my name. Let's get through that. So let's talk first about the process. There's this concept called threat modeling, and this is a pretty good description of threat modeling, and they get into a lot more detail in the paper, but you can look at it as a form of risk assessment that models aspects of the attack and defense sides. So looking at how to approach my risk based off of threats. What are the bad guys going to be able to do to my environment or to each one of my logical entities, where I will actually call them assets? Your web application stack with maybe your database and your web front end, that is an entity. Or your other services, you group them however you want to. I created my own definition because I wanted to hit on a couple of things. You want to be building this process that's repeatable. And at the end of the process, when you go through and you score a bunch of things, whatever you're doing, you have a set of actions that you can use to address the risks right now. What I don't want you to do is build a threat model process, spend a week in the conference room with a bunch of pizza with your whole team, and at the end you've got this giant binder full of things, or maybe the most complicated Excel spreadsheet you've ever seen. And then from there, you got to try and figure out, what am I supposed to do? Because now it's not really actionable. It's really hard to take advantage of it. We also want to make sure that what we're doing, we can prioritize. And that's one of the biggest problems I see when an organization is looking at their infrastructure that they have, or that they're going to have, or that they're going to maybe move into the cloud. And there's so many things that they've got to take care of. It's hard to figure out where to prioritize. And so we want to try and build a process that lets us prioritize appropriately, so we know what we're going to focus on, and we know on the things that we're going to wait. In the paper that accompanies this, there's a lot more detail into how you might consider setting up your process itself, and I'll take a look at that in a little bit. But what I really want to do is show you some ways in which you can prioritize and how you can manage making sure that you're addressing the risks. And then in this talk, I'll actually go through some use cases for, here's your web application, here's the threat, how would you manage it, how would you prioritize it? All right. So let's first look at how we would address the risks. You're going to do this, and figuring out how to address a particular risk. You're going to have one of four outcomes. These are really the only four things. You can kind of boil down whatever you're going to do to one of these. First thing you could do is you can mitigate. I would also say this is reducing the risk. An attacker can attack my system. They have capabilities in which to go after a particular threat. So I have a particular threat against my asset. I'm going to do something to make that attack harder to do, or easier for me to detect, or more manageable, or able to patch the system, something that reduces the risk. That risk still might be there, but it makes it a lot harder for the attacker to use it, and that's called mitigation. What would be better is to just eliminate the risk, like remove whatever that risk is altogether. Now, a lot of times when I look at people who are doing this, or organizations are doing it, or when I'm doing it in my systems, I'm re-architecting something, or I'm fundamentally changing the way the application is going to work. So in a particular case for a web application, if you're going to eliminate a threat, you're probably fundamentally changing that application. So it doesn't have that risk anymore. This can be expensive, and this could take a lot of time. It would be really great is if you have your threat model process and you start analyzing the threats before you start designing your application. Because then you can make a decision that, oh, if I add this kind of technology, that's a huge risk. Let me just remove it because it's not necessary. Or let me architect around it. I'll give some examples about that. The other thing you could do is transfer the risk. So if I don't want to mitigate or eliminate it, I want to just give it to somebody else and have them manage the risk. Now, if you're already in a cloud environment, you have already done this. You have transferred some level of responsibility to the cloud provider, and you're paying for it. I mean, that's what you're paying for. So as an example, if you're on-prem environment, you've got a room somewhere with lots of cooling that's got servers that you've racked up, and you've got base operating systems, and you have hypervisors, and you are responsible for all that. You are responsible for patching. You're responsible for access management to that hardware, all that kind of stuff. In a cloud environment, you've given that to the cloud provider, and you're now just responsible for the virtual machine. I've transferred some of that risk away. When we talk about transfer with the cloud environments, we're usually thinking about transferring operational responsibility. Like, I don't want to deal with that anymore. That's also the security and the risk. I transfer that. If you don't mitigate it and you're not going to eliminate it, and you're not going to transfer it, you're just accepting the risk. And this is really hard for a lot of people to, or especially managers, to really say, okay, yeah, I'm going to accept the risk. They never want to accept it. They're like, oh, I don't accept it. We're just not going to focus on it now. But you are accepting it, at least for a time being. I like doing threat modeling every quarter. I think it's a good time. So if at the beginning of January, or second week of January, you sit down, you figure out what the big threats are, you figure out where you're going to mitigate, eliminate, transfer. Everything else you don't have time for because we never have enough time to do everything. I'm just going to accept the risk for that quarter, and maybe we bring it up later. Since this is kind of hard to swallow sometimes, because as security folks, we never really want to accept it. We have something called the threat modeler's prayer. And I know it's silly, but CIO, grant me the serenity to accept the risks I cannot afford. I can't afford to do them right now, or I don't have the time or resources. And the courage to mitigate, eliminate, and transfer the risks I can, and the wisdom to know the difference. I realize it's silly. I know it's silly. But the big thing to look at here is I need to have the wisdom of understanding, where am I going to invest my time? Am I going to spend a little bit of time mitigating? Am I going to spend a lot of time transferring it? Or do I need to accept it? And in order to do that, I actually have to prioritize my system. So let's go into how we would prioritize. There's lots of different ways in which you could prioritize a threat model. I like Dread. Dread's pretty simple. It's a good starting point where you can build off of. So let's look at Dread. In a Dread model, what you do is you take each of your particular threats that you've enumerated somehow against your particular asset. So if you've got a web application, you have a forward-facing web application that provides some kind of service to your customers. I'm going to do a threat model against that particular asset, and for each of my threats, I'm going to score them on this Dread model. First thing you would score them on is damage potential. This is not just a technical damage, but it's a business decision too. Your business unit has to be involved to tell you what would happen if that service went down. If there's a denial of service, do I care if it's down for an hour or a day, or if I lose it altogether? What's the difference in that damage? So that business decision really has to be part of it. You also have to know what data is in that system, how it's being used, and even if it's not supposed to be out there, if you have a risk to a web application and that data is leaked somehow, there's a huge damage there that a lot of people don't even think about. So you got to think about the damage on the data and also the business case of that particular asset. Your reproducibility is how easy is it for me to initiate that attack over and over again? Is it something scriptable? Is it really hard? Do I have to jump through a lot of hoops in order to reproduce the technique? That's called reproducibility. Very similar to exploitability. A DDoS is a really good, easily to reproduce attack. I can do it over and over again. That's kind of the intention of a DDoS. Exploitability is how easy it for me to initiate and successfully use this attack or use this threat. that first time I do it. The affected users is looking at if I do this attack, how many users, which could be customers or internal, depending on who the users are for the system, how many of those users are affected and how much are they affected. That pairs really nicely with damage potential. And of course, discoverability. How easy is it for the bad guy to discover that there is this threat or this successful exploitation? And when you kind of look at this, you can kind of follow through how these all relate together when you pick a particular threat. On the right-hand side, the dread model gives you examples of how you would score. Basically, 0 is really good for you, 10 is really bad for you. So if it's really easy to reproduce, then it's a 10 because that's bad for you. If it's very hard or impossible, that would be a 0. The dread model, which in the links I have the link to the whole write-up, it gives you examples of what 0 and 2 and 3 and 4 and 5 is for each of these. But you got to make it your own. That you're going to be bringing your own biases, your own organizational culture, the expert knowledge you have on your team to this decision-making process. And so the way I would score things will be very different than the way you score it. And that's okay, as long as you use the same framework and template to score all of your systems. Because what you're going to do is you're going to get this average, and it's going to come out to a risk number. And that number doesn't mean anything by itself. But when you start comparing them to all of the systems that you're modeling or all the threats to all the systems that you're monitoring or modeling, then you're going to see that the items that are at higher risk than others. And this is where you can get into your prioritization. I've got things that are high risk. I should probably focus on those first. Now, this is a good starting point. I think you take this and you run with it. Add things in like how easy is it to mitigate? What's the cost level to mitigate? You can add all those kind of items to your modeling here. But this is a really good starting point, and I really do like the dread model. So let's take this dread model and let's apply it to a couple different use cases. So first use case is a standard web application with a back-end database. In this particular case, let's be very specific. Let's look at a web application that has a comment section. So I have, I'm a user, you're a user. We both can log into the system. I can put a comment down. You can read it. All right? So there's some interaction between the users on this web application, and it's open to the internet with some login, let's assume. All right. First problem is, how do I figure out what all the threats are against this asset? That's usually the hardest problem when you do threat modeling. If you've got a pen test organization or you've got red teamers that are available, either you're friends with them or they're part of your company, which is hopefully that's the case, you can leverage their expertise and knowledge to start enumerating the different risks. If not, you're going to have to go out and you have to do some research or go talk to companies and organizations that do this for a living. But if you're talking about a web application, you can always start with the OWASP top 10. This is an open resource, a product that anybody can go and get, and it very detailed explanation of what this organization sees as the top 10 most likely threats or attack techniques against a web application, how likely they are to happen, how successful they are, and then goes into detail exactly how you would do the attack and a whole bunch of different variations of those attacks. I love it. So if you're looking at a web application and a database, start with the OWASP top 10. Just start from there. So we're going to pick one. We're going to pick number 7. I think it's number 7. Yes. Cross-site scripting. It used to be higher, but it's a little bit lower on the list because it's a little bit easier to protect against than it used to be. It's not really a pen testing talk, but I want to describe this a little bit. We have our comment section for our web application. I'm the attacker, and I'm going to create a comment. And when I create that comment, I'm going to inject some JavaScript, let's say. So when you go into the page and you read the comment, your browser executes that JavaScript. And let's say that JavaScript steals your cookies and sends them to me. Now I can log in as you. All right, that's a cross-site scripting attack. Lots of different ways in which it could happen. All right, so what we need to do is we need to apply this particular threat to our particular asset and do our dread model. So hopefully when you look at this, if you've done this kind of stuff before, you'll look at this and in your numbers, you'll think, oh, why did he make that a 2? I would have made it a 4. Awesome. Apply your own logic, apply your own decisions to this. That's kind of the fun part of it. I did this as kind of looking at this fictitious web application. And for damage potential, I put it as a 2. Because when you do cross-site scripting, you're likely not blowing the whole system up. It still usually works as expected. It might be annoying, it might be an attack technique, but I didn't see it as a big damage. Reproducibility, though, I put as high. If I figured out how to do a cross-site scripting attack, I likely can do that same attack over and over again. So I marked it as a 7. I put exploitability as a 4. It's getting harder to initiate a cross-site scripting attack because we have better coding techniques and capabilities and mitigations. And so it's a little bit harder than it used to do an exploitability. But in this particular case, I made it a 4. It's really great is if you can test out these things. If you do have a pen test team, you can actually test in an environment, say how easy it is to actually exploit. Affected users, I put as a 4, and that's because in this fictitious asset that we're talking about, this comment section, not all the users are going to click on it, and likely if they do, I'm not going to do as an attacker, I'm not going to do something with all of the clicks. I would just pick one. So I kind of made it a 4. A little bit less than half. And then discoverability, I put it as a 7. That's definitely one that I would debate depending on the system, but people are attempting to do cross-site scripting, and they can easily determine if there may be an exploit capable, may not be able to get it to exploit all the way, but they can discover if maybe there's no mitigation in place. So all those scores, I got a 4.8. 4.8, I don't know if that's high or not. It's really relative to the rest of your systems, but it's probably about mid-range. So this may be one that I would want to go ahead and start evaluating, figure out how we're going to mitigate. So let's look at our potential outcomes. All right, I threw accept the risk off the raft because that's not interesting to talk about. So I'm either going to mitigate it, eliminate it, or transfer it. So I have this web application database that has a mid-level 4-point-something attack risk against it. First thing I could do is implement a web application firewall. I could put something in front of this web application that monitors all the traffic. And it has scripts or it has rules in it to try and determine when there's a cross-site scripting attack. This is actually fairly easy to do in the cloud. Most of the larger cloud service providers have an easy way of implementing their web application firewall. If this was a low risk, maybe I just use something that's out of the box, but maybe if it's a high risk, or in this particular case, if I did all the OWASP top 10 against my asset, I'd find out that web application firewall is actually going to stop a lot of them. Like that's a great mitigation for most of your OWASP top 10. I might find that SQL injection or one of the other attacks is a higher risk, and I want to put some more time and energy into it. Or I could go with a third party that the cloud providers offer and go in and download and run their system. So there's different options that you can take there. I could eliminate it by just re-architecting the website so there is no comment section. I know it sounds silly, but if you look at it, that's the only risk against this system is the comments that useful. You may decide, make a business decision, decide I don't want to do it anymore. I'm going to eliminate that risk altogether and not have to worry about it. And now I have a static website. That's one actually good way of mitigating these. Or I could transfer it by maybe going with a different company that provides comment tooling. So instead of me hosting it on my environment, they host it and pay some service. Or I move it to a platform as a service or a software as a service provider. So I could transfer that and have them take on. So as you go through each of these different ones, you're going to see that some of your mitigations will work across all your threats. And as you start prioritizing, you might decide, hey, I'm going to actually, the web application firewall is definitely something I'm going to implement, even if I can't eliminate or transfer everything. I can see across all the different attack techniques. And then you can start kind of mapping that out and see what's your bang for your buck. So let's take a look at something else. Not so much just the web application, but if you're moving into a cloud environment, you might want to take advantage of some of the new platforms that a web provider offers to allow you to operate differently. One of the things that companies are starting to look at is how to do DevOps, or more specifically, continuous integration, continuous deployment. Can I, as a developer, write code and have that deploy once a week, once a day, a couple times a day? I mean, instead of doing 6-week waterfalls and agile and things like that, I can deploy continuously. So if I can do that, that probably means that I've got a platform that does automation. So let's take a look at how we might do that with continuous integration. Continuous integration is this idea that developers are working off their version of code, but multiple times a day. That's where you want to do. You want to try and do it multiple times a day. That code gets integrated together and automatically tested. You may decide that every time that happens, if the test passed, you send it off to deployment. You don't have to. But for continuous integration, I'm bringing my code together multiple times a day. In order to do that, you have to automate your testing. So in our diagram here, I've got my 2 developers down here at the bottom. We check in our code, and it goes up to the source control server up in that top. And that source control server has a copy of the code that's getting ready to be integrated together. And then our continuous integration server goes and pulls it, takes that data, and does a whole bunch of tests, whatever we want it to do. We can have it test for, is the system operating as it's supposed to? We could do security testing. We do all kinds of stuff. And if it passes, it lets the manager and the other developers know that, yes, the integration is complete, or if it fails, it can tell you why. So this is a platform that we would use to deploy that web application that we were talking about before. In a continuous and automated manner, we can bring that code together. So let's look at a risk that we might have because we're using some of these kind of systems. What's a new risk in these new kind of platforms? And one of them is, let's look at credential disclosure. So in particular, let's look at this idea that I'm a developer. I'm developing on my the web application, and the web application is the one we talked about before, where it's a comment section. And so I have a database. And maybe in the test environment, there's a test database, and that test database has some small set of production data in it. And I connect from my local machine to that test database. In order to do that, I have to have some kind of connection information. We've architected this particular application so that there is a configuration file that has like a username and password or some other kind of credential in it. If I'm checking in code multiple times a day, I might accidentally check in that configuration file, and it will just get pulled into the source control. Let's make it worse. It's an open source project. So maybe now people on the internet can see my source code after I check it in. This is bad. If I do this, somebody else might be able to get access to that database. And even though it's a test database, it has data in there we don't want people to get to. So this is credential disclosure. So let's look at how the dread score for this. I put the damage potential as high. I kind of took the account that it is a test database. And it has a snapshot, so some of the data might be old. Maybe you are obfuscating some of the important customer data, but the damage is fairly high because they'll have access to the database. I mean, they have the connection file. It's easily reproducible. If I can log in once to a database, I can log in twice or 50 times. Exploitability is fairly high. It's logging in, it's making that DBA connection or database connection. It's fairly easy to do that if you have the credentials. I'm also making assumption that the database is accessible by the attacker and all that kind of stuff. Affected users I put is kind of low because it is a test database. If we were to model this threat against a different asset, say the production database, the production system, I think that the affected users would go much higher, right? Maybe all these numbers would go a lot higher. Discoverability I put is high because there's services out there, code that people have written that just are scanning open source data and source controls and all kinds of stuff in source code looking for credentials to make use of. So there's scanning software out there. Let's assume that if I check in my connection file into an open repo, it'll get identified and noticed. All right, so I have a dread score of 7. This is really bad. How are we going to mitigate it? Well, let's look at our 3 possibilities. What we could do is make use of this continuous integration server to constantly scan every time we check in for things that look like credentials. There are scripts out there that will look for things that look like private keys or SHA-1 hashes or username and password. It looks for the words username and the words password. So it looks for files that might accidentally get checked in. And your integration server can look at this, test it, identify that you checked in a connection file, and could block the integration. All right, that's mitigating it because I could get around it. I could do something really stupid and put my credential information in a comment or something else, and it might get past the checker, but it's a really good mitigation. Let's say that I'm really nervous about this, and I could go out to third parties and bring in other products that will help me do the scanning and look for more things than even just credential files, but we'll look for potential bugs in code and look for using other kinds of libraries that maybe have vulnerabilities. There's a lot of really great products out there that are easy to bring in as third parties into your cloud environment, and the cloud providers make that a really easy process to do. If I don't mitigate it, maybe I eliminate it by just moving to keys that are never getting stored as a file on disk. So some kind of temporary key system between the application and the database. As a developer working in that environment, I don't have to have the keys open all the time. I can maybe check them out, request them, and it only be in memory. That would eliminate this particular risk. Or I could just transfer that ownership to a third party or a second party who manages all the credentials for me. Your cloud provider will be able to do that for you in some cases with certain databases. So you could just transfer it, the key management to them. I think that transfer and that eliminate can kind of go together. You can kind of see where a particular solution can fit into any of those. So when you're looking at this, how you're evaluating your risks, and you're looking at your web applications, think about in a cloud environment, how can you also make use of the other tools that are used for deployment and analysis and looking for the things and trying to reduce your risk. There's really great opportunities to do that constantly, automatically, at any time. All right, so just to kind of summarize, you want to build this threat model process, and you're going to start, I would recommend starting small. Small team, small number of assets that you really understand, and sit in a room and figure out, okay, how am I going to get all of the threat information about this particular kind of asset? How am I going to score it? Am I going to use dread? Am I going to use weighted dread? You're going to spend a lot of time figuring out how you're going to do it. And then come out with it with a set of recommendations, a set of mitigations, eliminations, transfers, or accepting it. And then figure out how long you think it will take you to implement those, hopefully a short amount of time. Measure how well you actually are implementing those. You can measure your process the entire time. And then in a month, 2 months, 3 months, however you want to do it, start that process again, and it'll get better and get faster. And you can start measuring how well you are reducing your risk inside your environment, which is something really hard to do. We throw a lot of security controls at the problem, but we don't always have a way of measuring how much better we're getting. This kind of modeling with the prioritization should help you be able to measure how much better you are getting at reducing your threat and reducing your risk in your environment. Return to your threat model continuously. You could do like a big one every year, and then maybe every quarter a smaller team readdresses the problems. Fix your process. It's a living process. It'll never change. But what you will do is you'll start seeing that you're getting better and better, and you can go faster and faster. And big case about your threat model, make sure that your model creates something that you can prioritize and helps you be able to address each of the risks. And for that, I think that is it for me. Oh, let me one more. I have a set of resources you can go and look at. The big one to look at is the DREAD framework. If you just Google DREAD framework, you'll be able to find it. And then the SANS reading room is a great place for you to go to look at different threats against different kinds of systems, and gives you recommendations for how you would address each one of those. And I think that's it for me, so I will turn it over.
Awesome. Thanks, Shaun. Hi, everyone. This is David from AWS. And I want to start today by just taking a quick look at the service landscape within AWS, specifically around security. And as you can see in the diagram, we've got a whole bunch of native AWS services that you can use across your entire cybersecurity kind of implementation, if you like. And we've mapped these across on the diagram to the NIST cybersecurity framework, just to give you a reference point on where some of these services might be useful. Now, some of these tools are going to be really useful when you're tackling some of the threats that Shaun's talked about. So, for example, AWS Config and Inspector can be used to get information about your environment AWS config, for example, could give you information about whether your users and your developers are actually deploying approved infrastructure and whether they're meeting the security requirements that you've set up there. AWS Inspector can be used throughout the dev process and even integrated into the CI/CD pipeline to do vulnerability scanning of EC2 instances, looking for best practices, vulnerability CVEs, that kind of thing. And those rules are built and developed and maintained by not only the industry but AWS security experts as well. And another great thing about AWS in this space is a lot of these security tools are behind an API. So that's going to allow you to build up your deployment pipeline and actually automate some of the security scanning that Shaun's been talking about. Now, since we're focusing on web application security today, there's two services that I want to kind of double click on a little bit. The first one is AWS Shield, which is a DDoS or a distributed denial of service protection service. And what that's going to do is sit in front of your applications running on AWS and provide an always-on detection and mitigation to minimize your application downtime and latency. And Shield's actually available to all customers. There's no additional charge for using this service, and it's going to protect you from the most frequent network transport layer DDoS attacks. There is an AWS Shield Advanced, which gives you higher levels of protection from more sophisticated threats for applications that are running on EC2, maybe ELB, Amazon CloudFront, and you can subscribe to the advanced version, which gives you additional detection and mitigation against large DDoS attacks, as well as integration with AWSWAF, which we'll get to in a moment, and more importantly, 24/7 access to the AWS DDoS response team. So, AWS, you're providing that service to really help protect your applications. Now, another service here is AWSWAF, which is a web application firewall. Shaun talked about that in protecting, from cross-site scripting attacks, SQL injection attacks, that kind of thing. And AWS has their own WAF for you to go use. So let's dig into that a little bit. So what is AWS WAF? Well, it's basically a really easy to deploy service that you can put in front of either your CloudFront as part of your CDN solution, maybe in front of an application load balancer, or in front of your API gateways, or just your web applications, right? And because it's a service, there's no additional software to deploy. You basically turn on the WAF, tell it what you want to protect, and that's it, from a deployment of the infrastructure point of view. So it's super easy to use. Now, the thing you have to provide is a set of rules that the WAF's going to use to block traffic. And there's a couple of things here. First of all, you can create your own rules, and it could be based upon a set of rules already defined to block cross-site scripting. It could be filtering on IP address, HTTP headers, URI strings, and that kind of thing. And once you've defined these rules, you can actually go deploy them very easily within a couple of minutes. And part of the reason for that is, everything's behind an API. So again, thinking about your dev pipeline, you can actually be defining application-specific rules that you ship as part of your code and actually deploy as part of the application into the WAF there. Now, the way we kind of think about this from a self-service offering and in particular pricing is we price based upon how many rules you actually have deployed and how many web requests your application's receiving. So this is not a case where, I've got to deploy a piece of infrastructure and I'm going to pay a fee based on whether I use it or whether I don't use it. This is very much a pay-as-you-go pricing model, which you should be familiar with when moving to the cloud. Now, one of the great things about WAF is we manage all the infrastructure for you, so you don't have to worry about that. But you do have to worry about which rules that you need to go deploy. So if you're looking at your threat model and you're coming up with a list of things, you can go build that. Now, as Shaun mentioned, there is things like OWASP Top 10, which gives you a set of common threats that you should be thinking about. So one of the great things we've been able to do with partners is actually set up a list of or a set of packages that are basically managed rules for the AWS WAF. So in this case, AWS is going to still deploy the WAF for you, still using the AWS console. But when it comes to using or defining the rules, you're going to select from a list of partner offerings. And the one I want to talk about today is a couple offerings from Fortinet, which is on the diagram here. So, if you're thinking about, blocking against common threats such as the OWASP or specific CMS kind of threats or, emerging CVEs, you can go pick a rule set from Fortinet that basically has all these rules defined already for you. And what's great about that is if you go adopt those rules, you don't really have to think too much about, have you got the full coverage there? How do you actually define a rule to stop a cross-site scripting attack? Fortinet and the security experts there have already figured that out and packaged these up into kind of bundles. So they've got bundles for known exploits, malicious bots, cross-site scripting, and then a complete kind of package that covers everything. So if you're using AWS WAF, there's no infrastructure for you to manage. If you go use a set of partner managed rules, there's also no rules to manage. You're going to get continuous updates from the security experts at Fortinet on a regular basis, and it's really easy to set up. You basically go into the console, you're going to enable the WAF, and then attach, once you've kind of gone through the little purchasing process, you're going to attach the rules to the WAF there. And again, thinking about pricing, WAF has a pay-as-you-go model. All of the managed rules have a similar model where you're basically going to pay a fee per month for the rule set, and then you're going to pay per request. And just to give you a ballpark around this, all the prices from the different vendors are different based upon what they're providing. But even for the biggest package from Fortinet, you're looking at $30 a month, which is prorated hourly, with about, I think it's $1.80 for every million requests in there. So it's super easy to go budget that protection as part of your overall application. And it really doesn't matter whether your app's running as in S3 with API gateway, or maybe more complicated or sophisticated applications running on EC2. AWS WAF with the managed partner rules are going to help protect that. Now, Fortinet's a great example of a partner who's really working well with AWS and building out the solutions that you may be familiar with on premises and moving them into AWS and actually providing new integrations, as we've seen with AWS WAF, but also bringing some traditional services across here. Now, there's a couple of examples I want to kind of talk about here. One is Fortinet have built a quick start which allows you to deploy their FortiGate product onto AWS. Now, a quick start essentially is a set of CloudFormation templates which automate the deployment of services and infrastructure in AWS. So if you want to know how to deploy FortiGate in a secure fashion across multiple availability zones, configure all the network rules correctly, have FortiGate acting as a NAT gateway as an example, turn on auto scaling, the quick start is a place to go where you actually get code that deploys that for you. On top of that, there's also documentation and guidance around that. So it's not just a go run this piece of code. There's also an accompanying documentation that's going to describe exactly what's going on. And it's a great place for you to start. These things are designed to get you most of the way there, but there's always some adaptation you want to do for your specific environment. But as an accelerator there, I really encourage you to go take a look at the quick starts. And Fortinet's not the only vendor here in this space. There are plenty of others in marketplace that you can go look at as well. There is a new kind of capability available now that we're migrating workloads into the cloud, and this is providing security functions as a service. And in this case, we've got FortiWeb, which is a cloud-based WAF as a service. And essentially what this is Fortinet run in the same region that you're running your applications. They're going to run the WAF for you in their own AWS environment. What it means is you've got a set of experts and security consultants that are actually operating your WAF, and you're just going to pay a fee as you kind of use that. And again, you're one less thing for you to worry about, and what it's going to enable you to do is actually increase your security posture, harden a lot more of your applications without necessarily needing all of the security skills, to actually go do this yourself. In fact, what we find is organizations and customers typically do have the skills, but they have so many different business units and properties to kind of look after that, using these types of services really helps them focus on some of the other things there. And then finally, Fortinet have a Cloud Security Services Hub, which essentially brings together a lot of the management capabilities across different Fortinet tools to give you a kind of single pane on that. And one of the key pieces here is around transit gateway. So quick kind of scenario here, if I'm building a VPC with maybe the front end for my website in, maybe there's some database or something supporting that, but quite often these systems have to go talk to other back-end systems, and they might be isolated in different networks, they might be on premises, they might be in different VPCs on AWS, and essentially a transit gateway is going to help you kind of manage your network connectivity between those, and Fortinet can go build on the security there and provide a comprehensive view across all these different environments. Now they also have an AMI-based version. So we talked a little bit about the AWSWAF, which is an AWS service that is built and operated by AWS, but quite often you want to mirror things that you've got on premises, or maybe you want some extra functionality that the AWS WAF isn't providing. So in this case, we've got a machine image, or an AMI, which essentially allows you to deploy Fortinet into your environment. And again, Fortinet being a good example of an AWS partner that actually has done the integration to be able to auto scale across, the more web traffic you get, the more WAFs that can be deployed automatically by AWS on your behalf. And one of the great things about using something like Marketplace to get this is, if you kind of look at the diagram now, we've got two FortiGates in the middle that are solid color, and then we've grayed them out on the side. Rather than paying a kind of, buying 4 licenses, say, and not using 2 of them sometimes, or maybe buying 2 and then having to kind of quickly buy another 2, we can actually use an hourly pricing from Marketplace and pay for all those hourly. And if we find we're always running 2 of them, we can actually switch to an annual licensing model where we're saving about up to 70% in this case on there. And so we can use a mix and match of instances that are always on, coupled with instances that are going to scale to meet demand, and pay for that accordingly. So let's get on to a couple of customer examples here. The first one, since we've been talking about Fortinet, let's talk about one of their examples, and then we'll move on to a couple others. But this one in particular is pretty interesting because iCare is one of the largest insurers in Australia, with about 32 billion in assets, with an investment income of about 3 billion in total. It insures about 284,000 businesses and about 3.4 million employees. So you've got an insurance provider here, and obviously there's a ton of sensitive data and PII and everything in here, and they made the decision early on to go move a lot of their mission critical and customer facing apps into the cloud. So they needed a couple of things to kind of go right here. One is they really wanted an environment that was going to help them scale and help them, kind of with their security story. So they picked AWS as the target, and then what about security over and above this? How do we protect our applications? How do we make sure that we're looking at the right kind of vulnerabilities and doing the right thing there? So they worked with Fortinet, and Fortinet had to go dig into ICA's applications, look at the traffic requirements, look at the business rules and all that kind of thing. But they came up with a solution using FortiGate to actually protect the perimeter and within the availability zones as well. So internal segmentation can be protected in the same way. And it gives them a single plane of glass to kind of view their whole kind of vulnerability stance, if you like. So you can see, just make it out roughly on the diagram there. There's a couple of things we've been talking about with SQL injection and that kind of thing. So we can have a look at the types of threats we're getting and what, how we're protecting them. So, challenges pretty typical. We're migrating legacy systems across to the cloud. So whilst we're taking advantage of some cloud things, we still, have a lot of legacy constraints there. We're not going to move to a static website with serverless necessarily. We want to make sure that we're keeping our security bar high and we have the right visibility in there, as well as complying with any kind of regulatory requirements. And actually in Australia, there's, as you can imagine, Australian government information security mandate guidelines there. So using Fortinet, what they were able to do is basically reduce the overheads with the migration and the security, right? Because they're using a set of tools that are already providing those security capabilities. They have the rules and everything in there, and they can, just get going and move on to, other things the business needs to address. So we talk a lot about Fortinet, but there's some 831 products in the security category in the marketplace. So I thought we'd go through all 831, starting with Barracuda, and I'm not really going to go through 831. So let's talk about this. It's Smithfield, who produce, or one of the world's largest producers and processors of pork products, with facilities around the globe. So they're a multi-region global company, very forward-thinking in terms of IT, and again doing a migration of their infrastructure to AWS. And one of the key kind of things they wanted to address as part of this is that previously they relied a lot on outsourcing a lot of their management and data center operations, but as they moved to AWS, they wanted to really think about, are they using these vendors in the right way? Are there some things they could do better? Can they take advantage of some of the cloud native capabilities as well as some partner offerings? So again, migration, key consideration was, picking AWS because of the automation capabilities, but also because of the integration with partners. And Barracuda, again, have a set of products within AWS and outside of AWS, and they were already familiar with Barracuda's backup as a service. They really liked that product. So when they were moving into AWS, they were like, hey, let's check out this CloudGen WAF. Did a proof of concept, really liked the existing products and things, so went with Barracuda. And what it's allowed them basically to do is improve the migration project overall, because one of the big concerns every organization has moving onto AWS is like, can I maintain my security posture and all the things we've been talking about in this series of webinars. So Barracuda has really helped them kind of drop in a solution that gives them defense against those vulnerabilities, detection of zero-day events, as well as allowing them kind of granular access to management console and all that kind of thing. And then finally, we've got Yokogawa Electric's story, which working with Imperva on this particular one. Now, Yokogawa Electric is actually a company that produces a whole ton of different products and solutions. They're starting to be a more global company, so they have a lot of customers throughout the world. And if you're dealing with a global presence, then again, you're multi-region probably. Your web presence is very important, but also the bigger you are, the more of a target you are for the bad people in the world to go attack you. So again, as they were migrating to AWS, they wanted a way where they could make sure that they were hitting all of their goals from a security point of view. And like a lot of businesses, they have a security team, but not every business unit has cybersecurity experts available to go help with those particular applications. So as part of their move, they went with Imperva, purely because they could deploy this infrastructure in a very repeatable way and not have to have the security expertise on all of the business units or on all the dev teams, and they could come up with a repeatable pattern and basically protect their assets without needing all the cybersecurity expert to kind of work on this. So again, it's a great thing, when you can work on something like AWS, where you can capture repeatable patterns in something like CloudFormation or Terraform, and actually deploy these for your business units and for your customers in a very repeatable way. And all of these partners play really well in that space with auto scaling and all those kind of things. So Marketplace, one of the great things about Marketplace is actually just how fast you can go try some of these products out, right? So if you're sitting there and you're like, oh, I wonder what this Barracuda thing is, you can probably just go log into your AWS console, go find Barracuda in the Marketplace and deploy it. And in about 10, 15 minutes, you'll have something up and running to go try out. In fact, we'll talk about this. A lot of these security products have free trials. And then we have a very kind of flexible consumption model, very different than the traditional IT model of buying a license over a huge period of time. You can actually pay for these hourly. So if you want to spin something up, try it out and shut it down again, great. You're going to pay for a few hours usage there. If you have a very elastic environment, you can scale all of these products out and pay hourly across that. If you want to commit longer, you can pay annual prices, which gives you sometimes really significant discounts on that. So and you can mix and match those models as well. So very flexible there. From a SaaS point of view, SaaS is software as a service. In Imperva SaaS, you can just go sign up and start using it. There's no infrastructure to deploy. But for the AMI-based solutions where you're deploying it, or even the AWSWAF, it's really easy to go in there and get started. And you don't need a huge knowledge of AWS to go try some of these things out. And this is really good because sometimes the security team is well up on all of the security aspects of things, but when it comes to the mapping that to AWS, they're like, oh, all right, how do I do this thing that I do every day elsewhere? And Marketplace can help that really make it much easier. And then finally, we have humans to help you. So if you get stuck with something, we have a set of solutions architects that can help, and we have obviously integrated with support as well. So any problems or questions you have, we can usually get you an answer. So how can you get started? Well, all of the vendors that we've talked about today, Fortinet, Barracuda, Imperva, all have free trials available. So if you, the trick to this is go create a new AWS account that's isolated from your environment. You'll get a free tier usage there, so you won't pay for some of the AWS infrastructure. Go spin up the free trial, give it a test drive, go deploy a couple of simple apps and throw them behind some of these firewalls and have a play around with it. And you'll probably be able to do that for a few dollars in your environment and really learn some of these products and how they work and how you can use them within your organization. And with that, quick summary. First and foremost, you should be thinking about threat modeling, right? What are your vulnerabilities? What's the risk? how are you going to mitigate against them, right? And, as Shaun says, you can choose to not do things, but you should at least be aware of all of those aspects there. And a lot of the products that we've talked about and services can really help reduce the amount of effort you've got to put into to actually go tackle these things. Do take a look at the AWS services. One of the things we didn't mention is we have a fairly new service called Security Hub, which can actually take a lot of the data from things like AWSWAF, but also some of the partner products in Marketplace, and give you a single pane of glass across many different aspects of your security on AWS. Check out Marketplace. Products in Marketplace tend to be well architected, meaning they've been adapted for AWS. Some of them have even been built specifically for AWS. Check out the quick starts because, again, they've partnered with AWS architects to go build a solution that works. And then finally, go try out some new tools. There's a whole bunch of new vendors coming out, taking advantage of some of the cloud technologies. So do encourage you to go do that.